Hello. In this video, I'll outline how the Pathfinder NAV Fleet Portal strengthens GNSS resilience at fleet scale. Whether managing a small flotilla, a regional shipping operation, or a global network of vessels, the Fleet Portal provides centralized, real-time visibility of the GNSS environment across current conditions, emerging disruptions, and historical trend analysis. Fleet and technical managers can monitor the live GNSS integrity status of every connected vessel, identify developing interference zones, and respond proactively. This supports route optimization, risk mitigation, and operational continuity before disruption impacts schedules, safety, or compliance. By aggregating intelligence across multiple vessels, the platform builds a regional picture of GNSS health, enabling informed decision-making, coordinated advisories, and enhanced situational awareness across the organization. Let's explore the key capabilities. The Pathfinder NAV Fleet Portal is delivered as a secure, cloud-based software-as-a-service (SaaS) platform. Users can access the system via standard Pathfinder NAV credentials, or, for larger organizations, through Enterprise Single Sign-On (SSO) integration. The platform supports federated identity management using corporate identity providers, enabling authentication through existing directory services such as Azure Active Directory or other SAML OIDC-compliant providers. This allows organizations to maintain alignment with internal access control policies, password governance, and multi-factor authentication standards, while simplifying user lifecycle management. Role-based access control, RBAC, enables administrators to assign appropriate permissions across the organization, from read-only operational visibility to full administrative control for fleet configuration, vessel management, and user provisioning. At its core, the Fleet Portal is built around three primary components: a central operational map, a dynamic vessel panel, and a top-level control interface. The vessel panel, positioned along the left-hand side of the screen, automatically orders vessels by GNSS integrity status, ensuring that the highest risk or most degraded vessel is always visible at the top, eliminating the need to scroll during time-sensitive situations. Each vessel entry displays four primary integrity indicators: carrier wave suppression, CWS, jamming risk, spoofing risk, and interference level. These metrics reflect the most recent validated data from the vessel and provide an accurate, real-time representation of its GNSS health. Visual status indicators are color-coded to enable rapid assessment. Vessels transition from normal operational status to cautionary yellow and to red where anomalies are detected, allowing fleet managers to prioritize attention immediately. Selecting a vessel centers the map view on its live position, providing spatial context to any emerging issue, whether that relates to a developing interference zone or entry into a known high-risk region. Where collaborative data sharing is enabled, anonymized integrity data from nearby non-fleet vessels is incorporated into the regional view, enhancing situational awareness and strengthening collective GNSS intelligence across the operating area. The top control bar provides system status visibility and data configuration controls. It displays active user information, current portal resource usage, and management controls for the data streams feeding the operational map. The primary data stream delivers AI-aggregated GNSS integrity intelligence for a defined geographic region and configurable time window. Administrators can set the refresh interval, select the sampling period, and control how data is interpolated into the hexagonal spatial model displayed on the map. Aggregation modes can be adjusted to present either average values across the selected time window and hexagonal region, or maximum recorded values within that period. This allows fleet managers to analyze conditions from both a stability perspective and a peak risk perspective. Additional controls enable AIS layer activation, light or dark display modes for bridge environments, and access to extended features, including historical data streams, simplified map layers for bandwidth optimization, and place label toggling. The signal attenuation radius used in AI anomaly modeling can also be configured, refining how regional interference events are spatially interpreted and projected. The central map is the core intelligence interface of the Fleet Portal. Once data streams are configured via the top control bar, the map renders GNSS integrity intelligence in a spatially structured hexagonal grid. Each hexagon represents an aggregated analysis of signal conditions within a defined geographic area and time window. Operators can configure the visual layer to display specific GNSS threat metrics, including carrier wave suppression, CWS, jamming risk, spoofing risk, peak power events, and general interference levels. Hexagonal cells may be displayed as color-coded indicators for rapid situational awareness, or with embedded numeric values for more detailed analysis. Data is spatially interpolated using the Pathfinder NAV AI engine, which accounts for signal attenuation characteristics and proximity weighting to ensure the visual model accurately reflects underlying field conditions. For enhanced situational interpretation, the map can be tilted into a 3D perspective. In this mode, peak impact zones may be visualized as vertical intensity columns, and AI-estimated interference source locations can be displayed as directional vectors with highlighted origin points. When AIS integration is enabled, users can filter vessel types and overlay live maritime traffic onto the intelligence layer. The configurable heads-up display panel links directly to the selected vessel in the side panel and reflects the selected time sample. The time bar along the bottom of the interface allows operators to scroll through the active data window, replaying conditions across the selected period. As the time position changes, the map dynamically updates to reflect conditions at that moment. A regional aggregation mode can also be activated, highlighting peak-affected zones across the wider operating area for the defined time window, supporting broader situational assessment and strategic planning. Every data element within the platform can be interrogated in detail, including time, geographic origin, and event characteristics. Where data originates from vessels within your own fleet, full attribution is available. Data from external contributors is anonymized to preserve operational integrity while still strengthening regional awareness. We hope this overview of the Pathfinder NAV Fleet Portal has provided a clear understanding of its capabilities. When combined with onboard Pathfinder NAV units, the Fleet Portal provides organizations with actionable intelligence on current and emerging GNSS conditions at sea. This enables informed routing decisions, proactive risk management, and timely advisories to bridge teams, whether to avoid affected regions entirely or to operate with heightened awareness where rerouting is not feasible. The result is measurable operational value, enhanced navigational resilience, reduced disruption exposure, strengthened compliance posture, and improved risk positioning with insurers and underwriters. Pathfinder NAV delivers not only visibility, but strategic control over GNSS risk. To explore deployment options or pilot programs, we welcome a conversation with your operational or technical team. Thanks for watching.